Alright everyone, welcome to day 9 of Advent to Code. I am again about a half hour late, so no intro, we're going to get right into today's problem. This rope bridge creaks as you walk along it, so you aren't sure how old it is, whether it can support your weight. It seems to support the elves just fine, though the bridge spans a gorge which is carved by a massive river far below you. You step carefully. As you do, the rope stretch and twist. You decide to distract yourself by modeling rope physics. Maybe you can even figure out where not to step. Consider a rope with a knot at each end. Those knots are marked the head and the tail of the rope. If the head moves far away enough from the tail is pulled towards the head. Due to nebulous reasoning involving plank lengths, you should be able to model position of the knots on two-dimensional grid. Then, by following hypothetical series motions, you can determine how the tail will move. Due to the aforementioned plank lengths, the rope must be quite short. In fact, the head and tail must always be touching, diagonally adjacent, or even overlapping. Both count as touching. If the head is ever 2 steps directly up, down, left, or right from the tail must also move one direction. That is, direction remains close enough. Otherwise, if the head and tail aren't touching and aren't in the same row, a column tail always moves 1 step diagonally to keep up. Okay. You just need to work out where the tail goes as the head follows a series of motions. Assume the head and tail both start at the same position, overlapping. For example, a series of motions moves the head right 4 steps, then up 4 steps, then left 3 steps, then down 1 step, and so on. After each step, you'll need to update the positions of the tail. If this step means the head is no longer adjacent to the tail visually, then the motions occur as follows. S marks the starting position. Okay. Gotcha. You can count up all the positions the tail visited at least once in this diagram. S marks. Okay. So 30 positions tail visited once. Simulated. Okay. Huh. Okay. So we're gonna have a point for the head and a point for the tail. And then we're gonna need a list. We can do a set of visited. Right. As an input. Okay, and so the input, we'll just first start with doing the input. Why does it start getting crazy down here? Wait, am I like misinterpreting something? Right 4, up 4. Oh, moves to the right 4. Okay. Gotcha. Okay, so so S not split on spaces, and then we're gonna have to switch on parts. 0. So it's gonna be up, down, left, and right. Oops. Up, down, left, and right. Okay. I feel like I should have a direction class. Or not direction, right, enum. That way we can adjust a point. Well, we know that we can make some assumptions here. And then it's gonna be int count is gonna be equal to integer parse int of parts 1. we can make us some assumptions. And that is, we're gonna, well, actually, we'll just do it here. So for int I equals 0, well, I is less than count I plus plus. And so then the head's going to be equal to new point head dot row head dot column -1. So because of this, we know the head's gonna be moving, and so what we can do then is check if it's always moved diagonally, so it has to be touching in some way. So because of that, I don't think it follows. Okay. So because it's following, what we can do here is we can do if head dot row. Oh, I'm doing XY. I'm not doing row column. Okay, I should stick to row column. If it's row column, I should stick to row column. So if head dot row is greater than it can never move a direction and not be touching. Or it could ever be yeah, it's touching there. Okay, so if head dot row minus tail dot row and then math dot absolute on that is greater than 1, then what we do is tail equals new point, and it's just going to be tail dot row -1, and then it's going to always be head dot column. And that's just because it's always following. So no matter if it's to the right or to the left, when it moves up, it's always going to go diagonally towards the head. So that's why we can always just copy the head column. And then go ahead and add to visited tail. And that's all this is. Downs be similar, except for instead of subtracting 1, we'll be adding 1. This is the same, except if it is left, we are subtracting a column. Subtracting a column, and this now needs to be column instead of row. And then now we are now adding a column. And in theory, that should be all we need for this. I don't think I ran today's problem today. Wasn't 100% set up for today. Let's try it. Nope. Okay. Let's the sample inputs. Oops. So, 5. It should be 13. Huh. Huh. Wait, why am I doing head there? Wait. Why is that head? No. Wait, sorry, that's right. This is wrong. Now I got 12. Closer. What we're gonna do is we're gonna do a system out. Oh, 12, but I'm forgetting its initial position. So that's 13. Run this again. We get a much bigger number. And that number is correct. Hey, look at that. Rope snap. Sailing the river is getting a lot closer to you than you remember. The bridge is still there, but some of the ropes that are broken are now whipping towards you as you fall through the air. The ropes are moving too quickly to grab. Only a few seconds to choose how you arch your body to avoid being hit. Fortunately, your simulation can be extended to support longer ropes. Rather than 2 knots, you must now simulate a rope consisting of 10 knots. 1 knot is still the head of the rope, and the other moving accordingly. Using the same series of motions, as an example for both the knots, marked H. Okay. What if we have a head and tail, but it's always a head and tail, so it's no longer this? What if we just have, and this is, I'm gonna call this the snake because that's the best thing I can think of this. Snake 1, snake 2. Int I equals 0, while I is less than 2, I plus plus. This will initialize snake 1. S1 visited. We're gonna need an S1 visited and an S2 visited because there's gonna be 2 different snakes here. This is gonna be snake 1 dot get snake 1. Whoops, snake 1 dot size minus 1. Same with snake 2. Well, it's less than 10 because it's the length of 10, right? Yeah, okay. And snake 2. So because we have a snakes here, so what's gonna happen is every time we go, J equals 0 while J less than snake 1 dot size J plus plus, and we're gonna have to do this. We're gonna have to do point head is actually point head is actually going to be snake 1 dot get snake 1 dot get J. So there's our head. And actually we're going to have to add a case here if J equals 0. Continue. Just because we want to ignore this one. Because if it's just 0, we want to just move the head, we want to move the tail. Yeah, the tail comes next. Or no, does it? No, sorry, we always need to move the head. Never mind. Keep that there, move this there. Get 0. And then get 0 and set 0 to be head. Okay, so now we have head. Technically the head is actually snake.get J minus 1. So the head's already moved. Okay. Tail is gonna be snake 1 get J. tail, snake 1, or is it visit snake 1? Or S1 visit, there we go. That should correctly move it. And then all we care about now is if this is not true, we want to then break out of our for loop. I'm sorry, the microphone there. We want to break out of this for loop because now the tail hasn't moved. That means the rest of it doesn't move either. I think that is all. I'm going to copy this. Avoid move snakes up. Move snake up. Okay, and this is going to be list of points, and this is going to be snake. Snake, 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 snake. Turn to Boolean. No, we need to give it. We need the visited row. Set of points. This is visited. Okay. And so, given this, move snake up. We need to pass in both. So it's going to be snake 1, S1 visited, snake 2, S2 visited. And this should correctly move this. Okay. Now copy this. Change this to move snake down. And again, this is pretty easy because now it's just going to be row plus 1, row plus 1, row plus 1. Sorry, we don't move it here. It's already been moved by the previous movement. It's either been moved up here or it's been moved here because we're updating tail. But we have to also then in snake set J tail. We do need to do that. Okay. Should be good now. Row plus 1. Row plus 1. Good. Take this. Move snake down. Also, just copy this. Change this to move snake down. Move snake down. Okay. Move snake left. This is not very pretty, but this will get the job done. Left is column -1. This is tail, column -1. Don't make that same mistake again. We're going to flip these. This is head. Cool. Good here. Ideally, this is probably better if I had a like a direction I could put on these, because then I can just offset these by a direction, and that'd be much easier. But for right now, I don't. But that if you wanted to prove that, that would be the improvement there. I might do that to clean this all up in the end, but right now, plus and plus, and that is it. Okay, so now this is S1 visited, S2 visited. So 6494. The heck? 6494. Oh, and I broke it. This is where we should condense these all down to 1. So that's what I'm going to do here. So we're going to make a public or a private enum direction. down, left, right. Okay, and so we're gonna copy this, and this is gonna be move snake, and it's going to take in a direction. And so we're gonna need a method on here. Public move point in direction. And it's going to turn a point and a switch on this. Case up. Point p dot row, p dot column. Whereas row is getting subtracted. Down, left, and right. Down is adding one. This is subtracting one from over here. And this is adding one here. Okay. So now move snake. So now head is going to equal move point direction. Move in direction, give it head, or not do that, sorry. Direction, move point direction. And we can do that. So we move the point in the direction, but now it needs to follow it. And so I guess in theory, what we should be doing is this. If we subtract the head row minus the tail row, that means the tail is below, or no. It means the tail's below. That means the tail... And this goes down here. Right. That means the tail, if it's... The head is below the tail, that means... We gotta add one to this. That was way too complex. If the tail is to the left, that means we add one, subtract one. Alright, so now it should correctly follow. So now these all go bye-bye. And so now it's just move snake, and this is direction up. This is, come on. Down, down. This is left, oops. What? Left. Okay, we're just doing this. Right. Oh no, sorry, left, left, and then right. Left, left. No, 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 no. Left, left. Please, give me something. Well, So we need the row and column diff. If we have the row and column diff here, the row diff is greater than the column difference. Then we do this, and then we always set, we can just do this. So this is going to be row diff. Oh. Well, so this guy got to do it. Okay. Otherwise, we can do this, and now we can do this here. Is this correct? Probably not. No. Oh, maybe. 8575, 8575, 65, 55, 45, 44, row 4, column 3. Oh. So what is the else then? Else if they're both different. If they're both different, how do you do a system out print? Ooh. Print line. What are they both off by? I think I just gotta do it else if row diff is greater than 1 and column diff is greater than 1. I should get simplifying. So if that's true, what happens here is we just have to do both of these. No, it's if they're, yeah. Six, 5, 5. Oh, okay, wait. Where is it? It is this one. So 8, 5. 7, 5, 6, 5, 5, 5, 4, 5, 4, 4, 3, 3, 2, 2, 1, 1, 0, 0. Okay, I think we finally got it. And that should be 8836. All right, we got it. Okay. Wow. And the big number, let's take out this. Not that. Oh, yes, that and that. What's my answer? Hey, we finally finished it. There we go. Okay. Alrighty. Explanation time. So, welcome to day 9. Part 1 and part 2 are basically all done at one time. The only difference is that part 1 we have a snake with a length of 2 points. Part 2 is a snake of a length of 10 points. But other than that, they go through the same logic. What we do is we just go line by line of our input, parse it out into the 2 parts. The 2 parts is going to be the direction we're going and then the the amount we go in that direction, so right and then 1. We parse out the letter code into the actual direction enum we have made, which is down here. Parse those out, and then we then parse the count, and then we do a for loop for this, because it's going to be step by step. So for, in this case, up 2, we're going to have a loop that's going to run 2 times. That way it's going to move the snake up twice, because it goes grid by grid, it goes step by step. What it's going to do is, again, it's going to loop there, and it's going to move both snakes same time. So that we have 2 moves here, because it's going to be moving snake 1, moving snake 2. That's what let's do here. The move method, the way it works, it first gets the head of the snake, which is at position 0. It then calls this method on the direction enum, which is moving a point in that direction. All it does is goes through the 4 directions and adjusts the point correctly and returns a new point that is in the correct movement for that. So up goes -1 in the row, down is +1 in the row, left is -1 in the column, right is +1 in the column. We call that method here. Now we'll then update the head. We update that head on the snake, and then hold on to the head for the future for loop. So that will then move the head correctly given the direction, the direction we pass into it. Then we go on a for loop. This for loop is in charge of just moving the tails, or like the segments of the snake as needed. It first gets the new head. It's the head as in it relates to the current segment we're at. So each segment has a head one basically above it. So we get the kind of the new head for the segment, and then we calculate the difference in the row and column for that segment. If the row difference is greater than the column difference, that means we have to move diagonally. We have to move diagonally in the row. You cannot have a case where the row is greater than, or where the row or column is greater than the other one, with one of them not being 1. If you have this, you have to have you will only get a one of these has to be 1. So that's why we can get away with doing this, which is just then to then measure out which one is larger, or the head or row. In this case, if the head is larger, that means we need to increase the tail by 1, and then set the column to be matching the head's column. That will move it diagonally correctly into where the snake is at in the column. We just want to put it in the same column it is, because again, its column is only going to be 1 different. So it doesn't matter which way, we just set it to that head column. Similarly, if the rows are different, we do the exact same thing for the columns, where we add or subtract 1 accordingly, and then set the row of the tail to be the row of the head. Because again, it's only off by 1. It doesn't matter which direction. It's just going to be always going to the same row, so we don't have to worry about plus or minus here. Otherwise, if they are equal, then they can be a different number. But if they are equal, all we want to do is move it however this logic above here is, same way, but instead of doing that shortcut for the head of the head to the row or head to the column, we just set the column and head normally, but we check all 4 directions the same. That way it'll move diagonally in whichever direction it should be going. Then lastly, we update the snake's segment to what this tail segment is, and then we check if this is the true tail, which is going to be j is equal to the last base of the snake size -1, which is the last entry in this list. Only if that's true, then we update visited. We add this tail's position to the visited, and that's it. Once this is done with the movements, we can now then output the size the visited here. It's a set, so it won't have duplicates, and that's it. It's a hard problem to understand, and it's a tricky one to then code in, but explained out like this step by step, it's not too bad, but getting here is definitely a struggle. That being said though, that is day 9. Hope you guys enjoyed. I'll see you guys tomorrow for day 10. Peace out.